Hi, this is Chem 121, Chapter 4. In this lecture, we're going to do Section 4.9. In the first part of this chapter, we did Sections 4.1 to 4.8, where we learned about chemical bonds, the ionic bond model, and in Sections 4.7 and 4.8, we looked at the chemical formula for ionic compounds and the structure of ionic compounds. In Section 4.9, we're going to learn how to recognize and name binary ionic compounds. So to name cations for the main group metal cations in group 1, 2, and 3A, you name the ion by identifying the metal followed by the word ion. So it's pretty straightforward. To name these three cations, first you just identify the metal, in this case potassium, magnesium, or aluminum, and then you just add the word ion. So it's just a potassium ion, a magnesium ion, or an aluminum ion. In order to name an anion, it's a little bit different. You identify the name of the element, so in this case bromine, chlorine, fluorine, iodine, oxygen, or sulfur. But then to name it, you change the end of the name a little bit. So bromine becomes bromide, chlorine becomes chloride, fluorine becomes fluoride. So you change the end of the name of the element from INE to IDE. In the case of oxygen, you drop almost the whole end of the name. You just take the OX and it becomes oxide. And in the case of sulfur, you just drop the UR and it becomes sulfide. So the names of these anions are bromide, chloride, sulfide, oxide, or iodide, oxide, and sulfide. So for these individual atoms that become ions or anions, they're always end in IDE, ides, bromides, chlorides, fluorides, and this would be the same for any element in the table that's just an anion, a single atom that becomes an anion. It always ends in IDE. So in order to name compounds, and we've done a little bit of this already, we're going to name what are called binary compounds. So they just have two different elements in them. So for ionic compounds, they're always going to contain a metal and a non-metal. We always name the metal first, that's the positive ion, and we always name the non-metal second, and that's the negative ion. So to name ionic compounds, the full name of the metallic element is given first, followed by a separate word containing the stem of the nonmetal and the suffix IDE. So naming ionic compounds is pretty straightforward. You name the cation first, potassium, and you name the anion second, and just remember that anions always end in IDE. So this would be chlorine, but then we would change the end of that to IDE, so chloride. And then for this one, the cation is magnesium, the anion is bromine, but we would change that to ide, so it would be bromide. This third one, the cation is barium, the anion is oxygen, so we would just change that to oxide. So here's a little concept check for you. First you name the cation and then the anion, and always remember to change the anion, the end of that, to ide. So always remember to pause your recording and do these learning checks before you go ahead and look at the answers. So here we would have a calcium for the metal and an oxide for the non-metal, aluminum for the metal, and again, oxide for the non-metal. And here, magnesium for the metal and chloride for the non-metal. So to go the other way, we would have to write the symbol for the ion that forms from this element. So you'd have to look at where this is in the periodic table and write its symbol. And then you'd have to figure out the charge of the ion that would form for that element. Then same thing for the nonmetal. You'd have to figure out where this is in the table. And then based on where it is in the table, figure out the charge that it would have. And then we did an exercise like this in an earlier section. Just combine those two elements so that they would cancel out the charges of those two ions. So figure out where this is in the table, and based on that, what its charge would be. So write the symbol and the charge, and write the symbol and the charge for this anion, and then combine those two ions in a way that would cancel out their charge. Remember to always pause your recording and take a moment to work on these problems before you look at the answers. So sodium is in group 1. So sodium would have a +1 charge. I'm actually going to write these out on the whiteboard. So let me write these down really quick and then I'll do them on the whiteboard. Sodium sulfide, lithium chloride, and magnesium nitride. I'm going to walk through these real quick on the right whiteboard. So sodium sulfide. Sodium is in group 1. So sodium would form an ion with a +1 charge. Sulfide is in group 6. So sulfur would have to gain 2 electrons to get its octet. So it would have a -2 charge. So you would need 2 sodiums to balance out the charge on this sulfur. 2 sodiums and 1 sulfur would give you a formula of Na2S. Lithium chloride. Lithium is in group 1, so it would have a +1 charge. Chlorine is in group 7. So chlorine would just need 1 more electron to get its octet, so it would have a -1 charge. To get a formula that would balance out the charge on these two, you would just need 1 of each, lithium chloride. Magnesium nitride. Magnesium is in group 2. So magnesium would have a 2+ charge. Nitrogen, nitride, nitrogen is in group 5. So nitrogen would need 3 electrons to have an octet. So you'd have a +2 and a -3. So the easiest way to write this formula is to take this 3 and put it down there, and this 2 and put it over here. So Mg3N2. So all of the names that we have written so far are cations from metals that are in groups 1, 2, and 3. And really the only metal that's in group 3 that we're going to look at is aluminum. But cations from metals other than these groups can form ions that have what's called a variable charge. All of the cations that we've done so far have a fixed charge based on their group number. But metals in group 1 make a +1 charge, metals in group 2 make a +2 charge, and aluminum, which is the only one we're going to look at in this class, makes a +3 charge. So there's a few other elements that have a fixed charge, but I'm not actually going to make you guys learn these. So the only ones you need to know that have a fixed charge are groups 1, 2, and aluminum. You don't have to learn these other ones. You only have to know groups 1, 2, and aluminum. So all of the metals in groups 1, 2, and aluminum in group 3 have a fixed charge. So you always know what the charge is going to be. All of the other metals in the table, which if you look at the table, the majority of the other metals in the table don't fall in this group 1, 2, or 3. So they actually don't have a fixed charge. So for all of these other elements, all of these other metals in the table, you actually have to use a Roman numeral to indicate the charge of the metal because they don't have a fixed charge. They have a variable charge. So what that looks like when you write the formula is like this. So copper, which is one of these metals that doesn't have a fixed charge, you have to figure out what the charge of the copper is based on the nonmetal that it's in a formula with. So since a bromide's always going to have a charge of -1, you can look at this formula and say, okay, well, there's 1 bromine and 1 copper. So since the bromine is a -1, the copper must be a +1 to balance out that charge. So you write copper, and then in parentheses, you put a Roman numeral 1 to indicate the charge on that copper. So we write copper 1 bromide. When we come down here and look at this formula, FeS, iron is another element that isn't in group 1, 2, or aluminum. Iron would be in here in the periodic table. So since iron would have a variable charge, we have to figure out what the charge of the iron is based on the fact that it's in a compound with sulfur. Sulfur is in group 6. So sulfur would have a -2 charge. And based on that -2 charge, the iron must be +2. So we put a Roman numeral 2 in parentheses to indicate the charge on the iron. When we come down here for this formula, lead, which would be down here in the periodic table, it doesn't have a fixed charge. We have to figure out the charge on the lead. Well, that lead is in a compound with 2 atoms of oxygen. Oxygen is in group 6. Atoms in group 6 would have a -2 charge. And since there's 2 of them, that means this lead would have to have a +4 charge to balance out the charge in this compound. So we would write lead 4 oxide. So for each one of these compounds where the metallic element has a variable charge, write out the name and use a Roman numeral to indicate the charge on the metal. So we have Fe2O3. Iron is not in groups 1, 2, and it's not aluminum, so we know it has a variable charge. We have 3 oxygens. Each one of those oxygens is going to have a charge of -2 because the oxygen is in group 6. There's 3 of them, so the total charge on the oxygen is going to be -6. There's 2 irons, so the -6 has to balance out with the irons, so the total charge on the irons has to be +6. That means each one of those irons has to be +3, because +6 divided by 2 is +3. So the name of this compound would be iron 3, for the +3 charge, oxide. Down here we have cobalt, which has a variable charge. It's in a compound with 2 chlorines. Each one of those chlorines would be -1, but there's 2 of them, So that's a total charge of -2. So the cobalt has to have a charge of +2 to balance out the chlorine. So the compound would be cobalt 2 chloride. Now, going the other way is actually a little bit easier because for these compounds, you've actually been given the charge for these metals. The Roman numeral tells you the charge on the nickel, the charge on the zinc, and the charge on the iron. So you can just write out the symbol with the charge and then figure out the charge on the sulfide, the chloride, or the oxide, and then write out the formula for these compounds. So we have nickel 2 sulfide, zinc 2 chloride, and iron 3 oxide. Take a couple of minutes and see if you can figure these out, and then I'll go through them on the whiteboard. Always try to do these problems on your own. So the Roman numeral 2 tells us the charge on the nickel. So that's +2. The Roman numeral 2 tells us the charge on the zinc. That's also +2. And the Roman numeral 3 tells us the charge on the iron. So that's +3. Sulfide, that's in group 6. Group 6 is going to have a charge of -2 because group 6 elements need 2 electrons to get their octet. Chloride is going to be in group 7. That's going to have a charge of -1 because elements in group 7 need 1 electron to get to 8. And oxide is in group 6, so that's going to have a charge of -2. So now we're just going to balance out the charges. Nickel and sulfide, you need 1 of each. Zinc and chloride, you need 2 chlorines to go with that zinc. And iron and oxygen, you can just put the 2 down here and the 3 down there. So that's all for section 4.9.